All right, in this video, we are going to talk about finding the period of a sinusoidal function. Remember, for us, sinusoidal functions look like this. Y equals a sine bx minus c plus d, or y equals a cosine bx minus c plus d. If you look in other books or websites or videos, you might see where b is has to be positive in here. So I'm not making that assumption, which is why I have the absolute value here over the b. So just be careful about that. Other books and sources just assume that the b is positive. You can always make the b positive by using some identities, those even and odd identities. So where if b is negative, you can factor out a negative and then pull it outside to b with the a. Or if we're talking about the cosine, since cosine is even, if b is negative, you can factor the negative out and then just get rid of it because of the fact that cosine is even. But I don't make that assumption, so that's why my formula will have this absolute value in here. So just be careful if you're looking at another source. Okay, so remember the period of a periodic function is the minimum horizontal distance, right, that it takes for the function to repeat itself. For the regular sine and regular cosine function, it is 2 pi, right? If we look here, we can see that this is the regular sine function, and since we're talking about horizontal things now, I'm going to put the step on pi, and that will make it so that we can see those values a little bit easier. So this is the regular sine function, and remember the basic sine function just starts here at 0 and starts going up, right? And then it goes back down, and it's going back up, and it hits 0 going up again right here, and then it starts its cycle over and over again. So the distance between those 2 points is 0 and 2 pi. Likewise, if I look at the distance between any 2 peaks, right? Here, if I do 5 pi over 2 minus pi over 2, the distance between these 2 peaks is going to be 2 pi. Or the distance between 2 valleys, if I look at these 2 valleys and look at their x-coordinates, I have 7 pi over 2 minus 3 pi over 2. If I subtract 3 pi over 2 from 7 pi over 2, I get 4 pi over 2, which is 2 pi, right? So the distance between successive valleys, or minimum values, however you want to call it, or successive peaks or maximum values, is going to be 2 pi for the regular sine function. So if you do it by the midline, you do have to be a little bit careful, right? Because it crosses the midline either going up as you go from left to right, increasing or decreasing. So here, if you do it by where the point crosses the midline, then it crosses the midline again here, but you can see that it would be decreasing. The function's going down as you go from left to right. So you wouldn't want to measure it from here. You would want to measure it from where the function or where the graph is crossing the x-axis, increasing, going back up, right? That would be the correct way to calculate the midline from the graph. And so what we're going to be doing here is then varying the parameter b, so either increasing it, and you can see what that does is it decreases the period, right? You can see that now the peaks are much closer together, or the valleys are much closer together as well. It makes it smaller. And then if the value of the period is in between 0 and 1, you can see that that's going to stretch it out. Now the peaks are much farther apart. The closer that value gets to 0, then it gets more spread out. We require b not to be 0, right? Because if it's 0, then it's not a sinusoidal function anymore. It's just y equals 0, which is a straight line. Okay. So that is what's going to determine the period, is the value of this b right here. So if we go back and look for a sinusoidal function, either sine or cosine, right, and that matches this format right here, the period is 2 pi over the absolute value of b. Okay. And so if you have the formula, it's pretty easy. You just take 2 pi and divide by the absolute value of b. That will get you the period. Okay. So let's take a look at some examples here. All right. So on the first one, this one, y equals -4 sine. Oops, I left some stuff in there. Let me clear that out. So here I have this sinusoidal function. The absolute value of b would be pi, right? So that would be, let me get rid of these. So it'd be 2 pi over the absolute value of pi, like so. And you can see that that comes out to be 2. All right, so the absolute value of pi would just be pi, right? Since pi is a positive number. And then here I would have a common factor of pi on top and the pi on the bottom, so I can just cancel this out and it comes just out to be 2. So the period of this function is equal to 2. What if you, and that's how you can do it by looking at the formula. What if we had to do it by looking at the graph? Well, it's a little bit more difficult because of this value in here, this c that we haven't talked about yet is not 0, so that's going to make things slightly more complicated. But let's see, what you can do is, say if I looked at this peak right here, you can see that's at 0.137, and this next peak over is at 2.137. So if you did that and subtract, you would get 2, just kind of by looking at the graph this way. Let's see what it looks like when I change the step to pi, if that's helpful. So it still is, let's see if I zoom this out. Yeah, the peaks and the valleys still occur at kind of odd points, but let's see. This is sine, right? So yeah. So if we looked at the midline, I guess, the midline of this would be at -3. You could still do it that way as well if you wanted to. But on this, right, if you have 2 points labeled there, then you just subtract those 2 to get the period. On the test questions, just kind of thinking of how those are, or at least on the Newton assignment questions, they should have 2 points labeled for you to use. So they'd either label the 2 successive peaks or 2 successive valleys, or if they're using these points on the midline, they'll have them spaced out in the appropriate way, so you can actually see what the values are without having to guess. All right, let's look at the next example. The next example is 3 cosine pi over 2 x minus 5 pi over 6. All right, so looking at this one, it's going to be the period, right, is going to be 2 pi, oops, 2 pi over the absolute value of pi over 2, like so. You can see that comes out to be 4, but if you were working it by hand, right, that would be 2 pi over 2 like this. And then you are dividing, right, 2 pi by a fraction, so that's the same as multiplying 2 pi by the reciprocal, right, of that fraction, like so. And just to make it even more clear, that could be rewritten as this. And now you can see you have a common factor of pi, which between the numerators and denominators, that would cancel each other out, right? And then 2 times 2 is 4, over 1 times 1 would be 4, all right? So the period is 4. So again, pretty straightforward if you have the formula. If you don't have the formula, then what you're going to have to do is have some labeled points up here. This one, you can see if I do it by the peaks, this one is 1.667 minus negative 2.333. And you can see that comes out to be 4 as well. So between successive peaks or successive valleys, or you can use the midline, right? The midline here, I believe, is 2. And so here, right, if I look at the midline here, it's starting, and you can do it from any starting point, really. If you go over to where it's crossing the midline going up, the next place where it does it is this, right? And so you can see if I subtract this minus this, I'll get 4 again as well. Okay, so that's how you would find it from the graph.